Okay.
All right. Good afternoon, everyone. First, let me thank you for inviting me to participate in your two-day conference. It is a pleasure to be with all of you, especially to talk about this subject. As some of you are perhaps unaware, yes, I am a Marine surveyor, but when I'm not doing that, I teach at Rutgers University, which is New Jersey's state university. And I teach in the environmental and occupational safety program, and consequently do a lot of work with confined space training. So this is really a very, very important topic, and certainly one that we need to understand much more thoroughly if we're going to work safely as marine surveyors. So working in a confined space, believe it or not, is an everyday occurrence for us when we go about doing a survey of a vessel. Our big problem, and what I perceive, is the fact that we don't recognize the dangers that these locations create for us. So what I'd like to do today is spend a little bit of time talking about first what a confined space is. Let me just say that I unfortunately only have a half hour to do this presentation. Typically, when I am at Rutgers and at the Federal OSHA Training Center that is at Rutgers University, this is actually a 3-day program. So I'm taking 3 days of information and putting it into 30 minutes. So we're going to go through some of this stuff quickly, but at the end is my phone number and email address, and you are all welcome to contact me if you have any other questions about the subject at hand. So what is a confined space? Well, here in the United States, our OSHA, the Occupational Safety and Health Administration, defines a confined space that something that we can easily find ourselves entering. And a confined space has 3 specific elements to it. It has limited access and egress, is large enough to enter and perform work, and is not intended for human occupancy. Those 3 items, all 3 must be present. So stop and think about it. When we go on board a vessel, earlier today, I was quite intrigued by listening to George speak about the work that he does on some of these larger, more massive vessels, but even on board small craft and yachts, we can find a number of locations that meet this definition. And we need to understand fully what the hazards are associated with them. So look at this boat. This is a vessel that I recently had the opportunity to survey. Does this vessel have any confined spaces in it? Well, if you notice the construction of the vessel, certainly it does have some confined spaces. And one of the things that I needed to do was check and make sure, as all surveyors would do, that the bilge pumps, etc., were operating correctly. So to do that, what do I need to do? I need to open up these hatches and drop myself down into an area that is what? Limited in access and egress. One small way in, which means one small way out. It's large enough for me to perform work when I enter into it, and it's not intended for human occupancy. It's not meant for people to be in there. There's very poor lighting. It's very poor ventilation. It's just not meant for us to be there, although we might have to go in there and do some type of a task. So certainly we have to look at vessels that we go to and recognize that some of these confined space issues are in fact going to be present while we are at work. So what we want you to think about is OSHA here in the United States is concerned that spaces that are too small for complete body entry may pose hazards to employees, you and I, but they are not covered under the confined space standard. So what does that mean? If we take an opening on a vessel deck and we remove the cover and look inside at the fuel tank, okay, it's large enough to stick maybe our head or a hand inside, but we're not able to do a complete body entry. We still have to recognize that there are hazards, but it's not a confined space. We have to be able to physically enter into that space and work in order to go into it. Right? Certainly, these things are cramped. These spaces are cramped, but people can still enter and perform. If you look at your screen and you can see me, you can see that I'm kind of a big guy. And even I can get into some of these spaces, but they are cramped, especially for a fat guy like me. But ultimately, what you will say is that it meets that definition. I'm able to get in and I am able to do my assigned work, in this case, survey the vessel. Now, a couple of things that are always asked about the definition of a confined space, this idea of limited or restricted means for entry and exit. What does that really mean? Well, what it really comes down to is, do you have to use your hands to enter or exit the space? All right. You have to contort your body in any way to get in or out of the space. And is your entry into or your ability to get out of this space slowed down or impeded by physical obstructions such as engines, water heaters, and everything else we find inside of a vessel? So if the answer to any one of these questions is yes while you are at work, recognize that you are within something that we call a confined space. Now, here in the United States, unfortunately, we experience a tremendous amount of confined space fatalities. And I'm not talking in the maritime industry, but an industry in its entirety, workers going into sewers, etc. In the United States, on average, 125 workers of all types are killed in confined space entry. And ultimately, what has occurred is the federal government has said, we really can't continue that loss of life. So they've changed a few things which are really going to impact the way we think. So what happens? In 1993, believe it or not, quite some time ago, the federal government here in the United States changed the regulation and they added the term permit required confined space. Permit required confined space is a confined space. So those three things have to be there, right? Limited access egress, large enough to enter into and work, not meant for human occupancy, but the permit required confined space also has, right, an additional hazard. And that additional hazard could be a hazardous atmosphere, engulfing materials, inward converging walls that could trap a worker, or any other serious health and safety hazard. For us as marine surveyors, what we really need to be aware of is what we refer to commonly as the hazardous atmosphere. The hazardous atmosphere is what really is my main concern and what I want to spend a few moments about talking about today. And this is really critical, because what you will see is that when we look at these confined spaces, we have to ask ourselves, does the space contain or have the ability, the potential to contain a hazardous atmosphere? And could that potential atmosphere come about while we're inside of the space? Could things change? It could very easily be okay now, and 5 minutes from now become lethal. And yes, it could occur even quicker than that. And what I really want us to understand is that there is this critical concept of something called an atmospheric hazard. What are they? When we take a look at atmospheric hazards, what we can readily find is that atmospheric hazards are going to be placed into one of three unique categories: oxygen deficiencies, flammable vapors, and toxic atmospheres. Which of these can be found by the Marine Surveyor while we're at work? The answer is very simple: every one of them. All three of these types of things are going to be found while we are doing our typical marine survey. earlier today when George was doing his presentation and he was showing some of the work that he does on board these large ships. One of the first things that I noticed was the significant amount of rust found in certain areas. Well, believe it or not, that immediately addresses a specific atmospheric hazard, as we'll soon see. And it was really great to hear him say, when we work on our surveys, all of our workers carry a 4-gas meter. We're going to talk about them very quickly. I happen to have one of my 4-gas meters with me for this presentation, and I will tell you, it is one of the most important tools that you can carry in your tool bag while we're doing our work. So what is a hazardous atmosphere? A hazardous atmosphere, by a variety of different definitions, and those who write up these things, different organizations, all agree that a hazardous atmosphere is one that could expose us to the risk of death, incapacitation, impairment of ability to self-rescue, could injure us in some way, or cause an acute illness. The presence of any one of these makes the confined space a permit required confined space, which is the much more dangerous work location. So what I want you to be thinking about is, while you are at work, how could you encounter these? How could we find an oxygen deficient atmosphere? How could we find a flammable atmosphere? How could we find a toxic atmosphere? And I will tell you that a year or so ago, I was doing a survey on a boat, and we took the boat out for a sea trial. And as we were going up the river, I heard a beeping sound. And for a minute, I didn't realize what it was, because it was like almost at a distance. And I said to the captain who was running the boat, I said, "What's an alarm?" He says, "I don't know." He says, "We don't have any alarms indicating at the helm." And then I realized that the alarm was coming out of my tool bag. It was my 4-gas meter. In the bag, zipped, my 4-gas meter was reading 163 parts per million carbon monoxide. And that's out on the deck while we're going up the river. I took the meter and I walked over to the engine compartment hatch, didn't open it, stood on the hatch with my hand up in the air with the meter in my hand, and I was over 400 parts per million. We opened the hatch, and with my hand over the open hatch, I hit almost 5,900 parts per million. Now, had I gone into that compartment to do the evaluation of the engine while we were doing the sea trial, looking at all the things that we know we look for when we do these surveys, what would have happened to me going into a confined space with a toxic atmosphere of that level? Well, as it says, I ran the risk of death, incapacitation, impairment of ability to self-rescue. I would have died. There's no ifs, ands, or buts about it. I wouldn't be here today. So consequently, we really need to realize that these types of problems exist for us constantly while we are doing our surveys. So let's look at this, all right? The first one that I want to talk about is the idea of experiencing or encountering an oxygen deficiency. Normal air contains 20.9%. So I don't care where you are. You could be here in the United States where I am. You could be across the pond in England or somewhere in Europe. If you were to take a deep breath right now, you would inhale 20.9% oxygen. Once we hit an oxygen concentration of 19.5%, we are in what we refer to as a hazardous atmosphere. And what you will see is that extreme oxygen deficiencies can easily result in the surveyor going into a coma, becoming asphyxiated, or what you can see is we just have a impairment of our physical and mental capacity. We're not able to make good decisions, and consequently, we are not able to realize that this is happening to us, and therefore we stay in that area longer and get a more serious exposure. So how do we encounter an oxygen deficiency as a surveyor? It's very simple. The oxygen can either be consumed or displaced. Now, for surveyors, depending upon where we're working, we could experience either or. Most commonly, the oxygen is going to be consumed like when metal rusts in a tightly sealed space. We should all keep as a rule of thumb, if we were to open some compartment on a vessel and see that there is a significant amount of rust on metal components, okay, we have to ask ourselves, is there an oxygen deficiency present? Or there could be the decomposition of organic material, okay? And those of you who perhaps survey fishing vessels, there is actually a United States Coast Guard as well as a federal OSHA alert about oxygen deficiencies occurring on commercial fishing vessels because of decomposing fish, etc., that we could find in a hold. So consequently, we have that opportunity. Work at a shipyard where they're doing work, especially if they're doing hot work, welding and cutting, we very well might see that the area that is being worked on or an adjacent space is filled with nitrogen or argon to reduce the opportunity of having a fire on board the vessel while it's being repaired. And what they've done is, by pumping the nitrogen or argon, the inerting gas, into that vessel, they've now made it oxygen deficient. The National Fire Protection Association tells us that if we are going to do hot work successfully and safely, and we are going to do inerting, right, we should reduce the oxygen level down to 4% or less. 4% oxygen. If you do the industrial hygiene calculations, what you will see is 4% oxygen will be a lethal exposure somewhere between 30 and 60 seconds. Okay. Can encounter flammable atmospheres. Certainly, experiencing a fuel leak on board the vessel, we could experience a flammable atmosphere. Anytime we exceed 10% of the lower flammable limit, or commonly called the LFL, we are in what is referred to as a hazardous atmosphere. And certainly toxic atmospheres, most commonly for us, are going to be either carbon monoxide or hydrogen sulfide. We know a lot about carbon monoxide. We have requirements for installation of carbon monoxide detectors on vessels. If you follow the ABYC standards, you know that there is a requirement for CO detectors. What we don't realize many times is the hazard associated with hydrogen sulfide. Hydrogen sulfide uniquely does something to the body. It smells like rotten eggs, absolutely. But in a confined space where the hydrogen sulfide vapors are not readily dispersed, one of the things that the hydrogen sulfide does is something called olfactory fatigue. It takes away our sense of smell. And if we can't smell it, what do we think? We think that it's no longer there and it's okay for us to be there, when in fact it's not. So we have to recognize some of the specific characteristics of these toxic atmospheres if we're going to stay safe. So how do we stay safe? There really is only one way, and it requires an additional tool to our tool bag, and that is the carrying of air monitoring instruments. Okay, so what we really need to do is we need to get one and we need to use it. I don't go anywhere on board a vessel any longer without my 4-gas meter. This meter detects oxygen deficiencies, it detects the presence of flammable vapors, it detects the presence of carbon monoxide, and it detects the presence of hydrogen sulfide gas. Okay, it has the ability for me to attach a hose to it, so I don't even have to go inside of the space to measure or get a reading. I can lower the hose into the space, determine that it's safe, and then go into the compartment or wherever it is that I'm going and perform my survey. Critically important that we add this to our tool bag so that we can, in fact, stay safe. Really very, very critical. I'd be happy to spend more time, and I can see that I'm just about out of time. I'd be happy to spend more time talking about air monitoring instruments with you at a later time if possible. So what should we do? Obtain more training on the subject. One of the things that I would love to do with IIMS is do a 4-hour presentation on this subject and not rush through some of this stuff. What else should we do? We should purchase air monitoring equipment and recognize that these dangerous work locations are found on many vessels. Use your air monitoring equipment. Use them all the time. Your nose is not a calibrated meter. The air monitoring instrument is just as important as our moisture meter, our percussion hammer, and all the other tools that we carry in our tool bag. So if you have any questions, feel free to contact me at any time. You see my email address, my phone number. Those of you who are going to SAMS and the IMEC in October, I'll be there. I'm actually doing a presentation on the way to survey fire protection equipment on board a vessel and go over the new requirements for fire extinguishers. But feel free to contact me at any time. I'm not really supposed to talk about this, but we know that over the last year, there has been a surveyor fatality here in the United States that resulted from their entry in a confined space. So consequently, this can happen. And I certainly don't want it to happen to any of us. Please be safe. Recognize that confined spaces are a unique component on board the vessels that we go into. Stay healthy and stay safe. Thank you.
John, thank you very much indeed. Got a question from Gary who says, what is the fourth gas? Probably CO?
My 4-gas meter is oxygen, flammable vapors, carbon monoxide, hydrogen sulfide.
I hope that answers the question, Gary.